everyone.
All right, well, welcome everybody. I appreciate you taking the time today to join me on this webinar. I think we've got an interesting topic today. We'll be talking about creating predictive models within SQL Server machine learning services using R. We'll talk about Python a little bit. I'll get to that in a second. Quick introduction to me. My name is Bob Revoscale, and I'm a practice manager and consultant with Pragmatic Works. If you want to reach out to me afterwards, if you have questions or follow-ups, I have my contact information there. Email, Twitter, LinkedIn are all fine. I will likely have a blog post up over the next couple days with just some follow-up information from this talk, and you can find that at that link there. So yeah, feel free to reach out and talk to me. I'd love to hear from you, get some feedback on the talk, and again, answer any questions you may have. A little bit about what we'll talk through today. I'll start with just a very quick overview of what R and Python are and how they're used for machine learning. Then I'm going to talk about, I should have put this in quotes, but SQL Server machine learning services as a product and how R and Python are integrated into SQL Server, and a little bit about what that looks like. We're going to spend a lot of time then talking about the development experience. How do we write R and how do we write Python to integrate with SQL Server? So we'll talk about that. We'll talk about some of the nuances with how we actually execute R and Python from within SQL Server. And we'll spend the last portion of this doing a demonstration. Now, the demo that I've put together is built with R, but the patterns that I used and everything are very, very similar with Python. So if you are starting to use Python and you're not using R, stick with me, because I think that you're gonna learn a lot about just kind of the way that we develop and some of the patterns that are applied. And just to be clear in the demo, I'm not going into a deep dive on R or data science. So I'm going to be focusing a lot on how we integrate this R code with SQL Server and the power that we have there. A little bit about R. I thought that the story of its name was interesting. R, the language, was built or based on a language called S, and S was built by Bell Labs, and S was built for statistics. And it was named S kind of to follow along with a language that was becoming popular, which was C. So these single letter names for languages. And then two guys by the name of Ross and Robert built this language based on S, and kind of a take on their first names and the pattern of the day came up with the name R. And so that's what that means. R was really built from the ground up for statistical analysis. So that's where it has its roots. And that'll be important for us to understand as you're learning R. So R is open source. It's continuously being updated. People are making contributions to it, adding new features, fixing bugs where appropriate. But all this is managed by what we just call CRAN. And so I put a link to their website there, and this is where you can download R if you just want to run it. We'll talk a little bit about how this integrates with SQL in a little bit, but if you just want to download R, going out to the CRAN website is the way to do that. So Python, where R was developed really for statistics in mind, Python was really developed as a really general purpose language and really has become more popular over the last few years as a machine learning tool. So Python generally has more broad functionality than R. But as far as machine learning, they in today's day and age, they do similar things, R and Python. Like R, Python is open source, so similarly it's constantly being updated, and people are making contributions to it and writing new packages and enhancing existing packages, etc. I've listed a couple of the common packages that are available with Python that are specific to machine learning. R kind of on the whole is designed for stats and machine learning, so I didn't call out anything specifically there. But whereas Python does many, many, many things, these are a few of the packages that are pretty popular for stats and machine learning. So how does this all fit into SQL Server? If we recall, a couple years ago, after the release of SQL Server 2016, Microsoft introduced what they called R services, and this was at the time just R integration into SQL Server 2016. So we only had R. But with SQL Server 2017, they renamed it because now we have support for R and Python. And as such, they changed the name from SQL Server R services to more broadly machine learning services. And so now in SQL Server 2017 and beyond, we've got both R and Python. An interesting note here on Azure SQL database. So they just announced, I guess over the last couple months or so, the preview of machine learning services for Azure SQL database. And again, that is in preview, and right now it only supports R. And I can assume, I don't know, but I would imagine that support for Python would follow at some point. But for right now, this is only available with R. And again, that's in preview. So let's get this out of the way. Which one should I use? Should I use R or Python? And ultimately, there's really no right or wrong answer in that. A lot of it just kind of depends on where you're coming from, what your experience is, and so that would be kind of like choosing, whether I should choose Coke or Pepsi or Ford or Chevy. They kind of, in a lot of ways, do the same things. At least as far as statistical analysis and machine learning go, you really can't go wrong either way. And I think that this summed it up pretty well. I read an article on Quartz website, and the article was about trying to answer this question: which programming language should you learn, R or Python? And so I thought this quote here kind of summed it up. The great debate is settled. If all you're doing is data analysis, it doesn't really matter which one you use. So again, it's up to you, R or Python, for your machine learning, particularly in SQL here. It's up to you. I think I focused on R today for this demonstration, mostly because that's the one that I learned first as far as machine learning, and that's really the only reason. I mean, I've done a little bit of Python, but in the interest of time, I just focused on R for today's demo. So if we have R and Python, I mean, why would we want to use R and Python within SQL Server machine learning services? And I've listed out a few reasons here. Pretty often we're using R or Python to connect to SQL Server because that's where our data is, right? We've got all this data, we want to analyze it, we want to do advanced analytics, and all of that data is in SQL Server. So we can take advantage of running the R and Python process on the same server, the same instance really as your data. So having the data very close to the R and Python processes will reduce latency. Ultimately, it just makes it simpler to integrate analytics and machine learning into your application. I'm going to talk about this a little bit more in a second, but when we install SQL Server machine learning services, the R and Python versions, for that matter, are a little bit different. They're kind of like amped up versions of the R and Python that you would download from the open source sites. So specifically, there's some enhancements around parallelism, and there's some performance enhancements for dealing with large data sets. And so that's a key advantage to why we would use machine learning services, or R and Python within SQL, versus just running R on its own. And then another key advantage of doing this is really the version management. So I mentioned both R and Python are open source, and packages are continuously being updated, and people are making changes, etc. And for an enterprise, it's really hard to manage that. And generally speaking, you're doing some statistical analysis, you're doing a lot of experimentation, and kind of the nature of that is that you're downloading packages and you're trying new things, etc. And if you're not doing if downloading those packages and managing that, it can just introduce a little bit of risk into your environment. And so that the R and Python instances are managed by SQL Server is another reason to use R or Python within SQL Server. Couple notes about it, not the architecture necessarily, but kind of how it runs. Machine learning services is not installed by default. So this is something I'll show in a second. We have to enable explicitly. And it's really important to understand just architecturally that R and Python, while there is a tie with SQL Server, they are running outside of your SQL Server process. And so SQL Server interacts with R and Python via this service called the SQL Launchpad. And I've highlighted this from my task manager on my local machine. I have 2 instances of it because I've got 2 SQL instances running machine learning services. You can kind of see the names there. I've got one version running SQL 2016 and one in 2017. So again, SQL Server uses this Launchpad to interact with the machine learning services. Just quickly on the installation here, actually there's some really great blogs online and instructions and tutorials about how to get set up with this, but I'll kind of boil it down to this. You do need your installation media to install it, and to do so, you choose the option there for installing machine learning services in your database, and then you have the choice of installing either R or Python or both. And then once you've installed it, we do have to change a configuration, and that configuration is allowing SQL Server to execute external scripts. So we're going to talk more about this later, but this kind of gets to that idea that SQL Server is calling out to separate processes when we execute R or Python, and it does that via what they call external scripts. And so we just need to make sure that our instance is configured to use external scripts. Generally, it's turned off by default, so you want to enable that, and after you enable the external script execution, you'll just have to restart your instance. And after you restart your instance, Microsoft has a couple, and there are a lot of these out there, but just kind of those hello world examples, just making sure or verifying that your R or Python instances are running. And so to do that, we just run this stored procedure, and I'm going to talk more about this later on, but this SP execute external script is how we run R or Python from SQL Server. And so inside the red boxes here are just very small snippets of R code. There's a small snippet of R and a small snippet of Python, and that this returns a result without failure just tells me that, okay, R and Python are running and I can connect to it from SQL Server and we're ready to proceed. So that's just a little bit about how you can verify whether R or Python are running. And I'll show this a little bit in a demonstration. And again, I'll talk more about this stored procedure called SP execute external script, because that's a big part of the process here. So let's talk a little bit about what happens when we do that installation. So we install R, we install Python, what comes with it. Let's start with R. When you install R, it's actually installing what's called R Open, and this is Microsoft's distribution of R. Currently, it's based on R version 3.5.1, which is generally available R release. You can pull that down from CRAN. So that's just your base R. But it also installs a couple of things here that I've called out. One of them is called Revoscale R, and the other one's Microsoft ML. I'll talk more about those in a second. Python, there's no separate Microsoft distribution of Python. Right now, if you install Python, you're going to get 3.5.2, which is based on Anaconda 4.2. That's the distribution of Python that's included with machine learning services. And similarly to R, the Python installation on SQL Server includes these 2 additional packages, among other things, but the Revoscale Pi and this Microsoft ML. Let's talk about these a little bit more. So again, R Open is Microsoft's what they call their enhanced R distribution. They've added functionality for multi-threading R, so R natively is not multi-threaded. With R Open, you can run it multi-threaded. The other reason that Microsoft does this is because, kind of getting back to the notion that it's open source and R is constantly being updated, this is kind of a way for Microsoft to certify, so to speak, that, okay, this version of R is stable, we've tested it, it works in our environment, etc. Therefore, that's the one that will be packaged with SQL Server and deployed. So they can kind of manage some of the noise, if you will, of community commits and updates, etc. A little bit about Revoscale. So again, these Revoscale packages come with the R installation and the Python. The name comes from Revolution Analytics. So Revolution Analytics was a company that Microsoft eventually acquired, but they built some R packages designed for high performance. So specifically, they did a lot of work on parallelism and then also the ability to work on some of these larger data sets. And we'll talk a little bit more in the demo about Revoscale, but that's what gets installed with machine learning services when we do R and Python. And then quickly on the Microsoft ML, Microsoft has developed a package with some additional machine learning functionality. So a couple specific examples is that they've provided some pre-trained models. I left something off the list there, but they've got one for image classification, and I wrote this down, but I don't have it in the slide, but there's another key piece of functionality around pre-trained models that they've supplied. So the point of this slide is to say, yes, when you install R and Python, you kind of get that base code, but you also get a couple extra features that Microsoft has provided with you. Now we understand that R and Python are open source and they're both being updated, and so Microsoft understands that. And so how do we update R and Python in our SQL Server instance? And the simplest way is really just through your cumulative updates in your service packs. So when service packs are released, they will include any updates that Microsoft wants to provide for the R Python environments. I don't have a whole lot more information on this, but Microsoft does have a product that it's called the Machine Learning Server, and this is something you can install from the SQL Server installation, but this is really just your machine learning components and not the SQL Server engine, but it's managed as a different product. And so what you can actually do is take the R or Python installation that you've bound to your SQL Server instance, and you can actually, without harming how SQL Server interacts with it, but you can kind of rebrand, if you will, your R and Python to be considered part of the Machine Learning Server product. And the reason you would do that really is because Microsoft provides more frequent updates on that product because it's just the machine learning functionality. Whereas if you're doing it with SQL Server, it's all wrapped up with other cumulative updates and it's not just dedicated. You can also do just your manual updates. I mean, we can pull down our own packages in R, and that's pretty simple to do. People do it all the time. It's just that when you're dealing with a server environment, it's just generally not recommended to do that manually, just for a number of security and administrative reasons. So really the simplest thing to understand here is that if you are applying your service packs, your versions of R and Python will get updated as needed. All right, so switching a little bit, I'm going to talk about getting into development and how do we write code in R and Python that can be executed from SQL Server. And if you're just getting started with R and Python and SQL, this is a really, really important concept to understand. And I took this image right from Microsoft's documentation. And the highlight here in red is that Microsoft, in fact, even recommends that basically you don't write your R or your Python, for that matter, inside of T-SQL. But what you would do is you would work inside of a development tool for R or Python and kind of work out your R Python code, do some experimentation, etc. there. And then you're just going to integrate kind of the outcome of that code, if you will, into your T-SQL. And we're going to go through this in a demo pretty heavily, but I just want to make sure we all understand that, generally speaking, again, if we're developing R or Python, we're not doing that from within Management Studio, for example. If you're using R, a really common or popular tool, and I've used this one quite a lot, is called R Studio. It's a great tool for writing R. Visual Studio also has support for R, and there are many, many, many other tools for writing R. Similarly with Python, I've talked to a lot of people that have found that Visual Studio Code is good. I've used that. I just haven't done as much personally with Python on the ML side. But I know that that does work pretty well, and I've talked to other people out in the field that are using Visual Studio Code. And there are many, many other tools for Python as well. But just understand that if we're developing R and Python for SQL, you'll likely want to use a tool other than a SQL tool for writing that code. And this kind of summarizes a little bit about what I was talking about there. Inside of our R or Python IDEs, where we do a lot of our data exploration, getting connected to data, kind of maybe doing some visualization of that data, some histograms, doing some correlation plots to try to understand what our data looks like. We might do some feature engineering, but then also experimenting with different models, right? And we're going to go through some of this in a demonstration, but trying to find a model that is the best predictor of your business situation. But you would do all that type of work inside of your R or Python IDE. And once you've kind of got your model figured out and you understand what's going to work, you kind of take just pieces of that code and integrate that into SQL. And really the purpose of that then is really more from an operations standpoint, where we're starting to talk more about app integration, where we say, okay, I've got some data in SQL, and I've got this R model kind of defined, and I want to tie those two things together. That we would do in SQL and in a tool like Management Studio. So that's just kind of the, at a high level, the experience there of where and why we write our code. Yeah, so a little bit more on that stored procedure that I mentioned earlier called SP, execute external script. So this script, or I'm sorry, this stored procedure accepts as a parameter a string that can be either R or Python in our case here. And we're going to walk through this pretty heavily in detail. But what that script will do then is actually invoke through that launchpad. It'll pass that script down to either R or Python and then execute the R or Python via that separate process and then return results back to SQL Server. So that script can include the R Python code that would create a machine learning model. It can train a model, but then we can also, after we have a trained model, we can actually use this different script then to run the prediction, to say, okay, I've got this data set and I want to run it through this model and return some output. We would write scripts and pass those as parameters to this SP, execute external script. This page here is mostly for reference. We will provide these slides sometime after the talk, and we will cover a lot of this in a demo here shortly. Now, one thing that's really, really cool, I thought this was really a nice feature. With SQL Server 2017, they introduced a new function. This is native to T-SQL, and the function is called Predict. So this is available in SQL Server 2017 and later. It's also available in Azure SQL Database. And a couple things to note here are that this predict function runs natively within SQL Server. This is not calling out to R. And so now what you can do is just run a query, and I've shown just the sample here, and this I took from Microsoft's documentation. We will do a demo of this. But this is just a SQL query that invokes this predict function where we give it a model and we pass it some data, and it's going to return us a predicted value just in a query. And again, we're going to do a demonstration of this, but it's important to understand that this runs within SQL and it does not require machine learning services on that instance. So if you've developed a model and you can get the binary output of that model, which we'll talk about in the demo, you can run that from another server instance. And we're going to talk about that function here shortly, but this is a really, really powerful piece of functionality that's available with 2017 and later. So kind of going back to developing in the IDE and the pattern that we're going to follow, this here again is kind of here for reference. We're going to walk through this in a demonstration here in just a few minutes. But what is the pattern for how we integrate our R or Python to do predictions? So after we've spent some time we're going to do RStudio today, and we've done some data exploration. We've built a couple models, and we figured out which one is the best, and we understand the model we want to use. After we figure that out, now we're going to switch over to SQL Server. And there are lots of ways to do this, but what we're going to do today is we're going to start by creating a stored procedure, and that stored procedure will build a machine learning model with R. The output of this stored procedure will be the binary structure of that model. After we have that output provided, this binary output, we're going to take that output and we're going to store it in a table, which is my second step here. The reason we store it in a table, it makes it a little bit easier to kind of manage the process, isolating processes. I've got one thing to do the training, I've got another to do the prediction. And so like the steps 1 and 3 of creating the model and running the prediction are separate. But having these model in a table allows us to keep history of the model. So if I retrain the model periodically, if I get new data coming into my system and I want to retrain the model to use refreshed data, I can keep history of those models in a table. But I can also maybe store models with different algorithms and kind of see how they correlate to each other over time. So the second step there would be to take that binary model output and store it into a table. And then finally, we want to use that model to run predictions. And so we'll do that through a stored procedure as well, where we will provide this model as input to a stored procedure. We'll provide some data for which we want to do some prediction, and that stored procedure will return us predictions. So, whoops, skipped one. There we go. With that, let's talk about our demonstration. So, this demo is something I got from Microsoft. So, if you want to, try this, you can go out to the links I've included here. Again, I did this with R. There's a link here to the Python materials. So the same pattern that I just described above would apply to Python the same way it does R. And the demo is based around a scenario where we're running a ski lodge, and we've got some historical data about the number of ski rentals that we have, or number of sets of skis that we've rented. And so we want to take a look at our historical rental data and generate a prediction of what our future rental activity may be. What I'll do in the demo is I'm going to start in RStudio. We're going to walk through how we would use R to build and test a couple of regression models. And then from the two that we're going to build, we'll choose one that we determine to be the better of the two. And then I'll move into SQL Server, where we will then build that trained model and execute and generate some predictions. So let me jump over first to SQL Server Management Studio. And quickly here, I just want to show you these scripts that I mentioned earlier about just verifying that my environment is set up correctly. And so this is the first one that I'm running here, just making sure that my instance is configured to run external scripts, and that this is set to 1 means that I'm all set to go there. So I know that that's turned on. So I don't need to do this enabling here. And then I've just got this simple query here to verify that R is running. And this just takes a second. And the fact that this just runs is all I need to see. In addition to providing a script as a data set, I also tell it what language I want to run. And so I told it here I want to run R, and sure enough, it returned me some output. So I know that it can run R from SQL. And then similarly with Python, I said I wasn't going to do any Python. This is, I guess, not entirely true because I've got a small piece of it here. But again, all I'm trying to do here is just to verify after I've done my installation that the Python is running. And again, the fact that this ran without failure is all I'm looking for here. And you can see here that I've just told SQL to execute a Python script. Okay. Quickly on my data set here. So I've got a data set, and again, this is available. You can download this from that link that I showed you earlier. And so this is just, I've just got one table with year, month, day, and just historically, how many sets of skis did I rent? We've got some fields in here telling me what day of the week this day was, whether it was a holiday, and whether it snowed. And so we want to build a model based on some of these inputs to predict what our count of ski rentals might be for a future or a day in the future. All right, so now I'm going to hop over to R Studio, and this again is where I'm going to develop my R code and do some model testing, etc. So I'm going to walk through this kind of quickly. Again, I don't want to do an R deep dive here, but I'll walk through some of the basics here. Right at the top here, I'm creating a connection to my database, which is just sitting on my machine here locally. I'm going to run these pieces of code kind of in sequence here, little by little. In my R environment here, R Studio, it will remember pieces that I've executed prior. So what I mean by that is if I've defined a variable here called connection string, it's going to keep that value over here in the upper right-hand corner of my screen. And now I've got this value for connection string available to me. Using some functions here, I'm going to connect to my data in my database. I can do that a couple different ways. I can either connect directly to a table itself, or I can provide a query string. For today, I'm going to use this query string here, where I'm just pulling these fields from that table that I showed you a second ago. So I'll just run this. And so this is just defining a data set object, and right here is where this starts to get good. I'm actually going to run that query and import this data into my R environment. And so I can see up here in the upper right that's telling me that I've got a data set here called rental data, and it's got 453 rows with 7 variables or columns. Okay. I can use R to kind of take a look at that data. I can look at the str as a function for looking at the structure of a data frame, which is kind of analogous to a table here. So it's telling me a little bit about the data, shows me a sample of it, the data types that I have, etc. I can also use this head function to just look at a sampling of rows from there. And there's also a really handy function in R called summary. And so I can do a summary of, I've picked one field here. So the rental data is my data frame, rental count is one field, or I can just do a summary of the entire data frame. For right now, I'm just going to quickly do the summary of the entire data frame and show you what that looks like. But if I'm a data analyst now, this type of information can be, helpful to me. I can get, so looking at rental count, for example, it's going to tell me the minimum value, the maximum value, and some of these quartiles that would be used in like creating a box plot, for example. So again, this is just some of that analysis that I can do from R Studio. We'll see here shortly that this is the kind of stuff that I don't need to translate over to SQL necessarily. Now I want to start working to build my model. To prepare my model, I've got these fields called holiday, snow, and weekday right now that are integer values, and for the purposes of my model, I want to convert those to what we call factors, meaning I want those to be more categorical and not numeric. because the numeric value of 1 through 7 of a weekday is not really important, but just that they are different is important. So that's what I want to do here. So after I've made that change to my data frame, I'm going to run this structure piece here, and I can see that in fact it has changed my weekday, holiday, and snow to be factors. And you can see like it puts the values in quotes here, kind of indicating that they're not numbers any longer. So this all looks good to me. This is fine. Now the next thing I want to do, I want to split my data set into 2 sets. I want to create one set to train my model and another set for testing it. And so what I'm doing here is I'm saying I'm going to create a training set with all of the data where the year is earlier than 2015, and I'll use that to kind of build the prediction or build the model. But then I will take the data from the year 2015 and actually validate it. So we know what the results were in 2015, and we can run them through our model to see how well the model predicted the actual outcome. So right here I'm just creating 2 other data frames with training data, test data, and that's fine. So I can see up here that it's created 151 rows of test data and 302 rows of my training data set. I'm going to take the actual count of my test data and store that here. I'm going to use this in a second down below to do some comparisons. So I'll just run that. So now I've got my actual values stored. And now here this is where this actually starts getting pretty good. I'm going to create 2 different models here. I'm going to create a linear regression model, and I'm also going to create a decision tree model. And in a nutshell, what this is doing in both cases, it's I want to predict the value of rental count based on these inputs here, is essentially what this is saying. And I'm going to use the data, my training data, to train both of these. And so quickly, I'm just going to run both of these. And now I've got my models defined. And so I just have the model. The next thing I want to do is I want to run the prediction. I want to use this model to predict how well, or well, we'll run the prediction, then we'll compare to see how well it did. I'm just going to do both of these at the same time, where I am using this model with this data set. So again, I'm passing in the 2015 data into the model, and it's going to predict for me the rental count. So I'll run both of these here. And so that ran, and then just quickly I'm going to look at using this head function, just looking at the sample output here. And what I see here is that it provided this rental count prediction. So just looking at a sample here, the actual rental count was 42, it predicted 27.5. But for this one here, the actual was 360, it predicted 387. And then this other one down here, the decision tree, just a couple samples, this actually was 42, it predicted 40, and so on. So what I want to do now is I've got these 2 models, and I'm just going to run this piece of code here that's going to plot for both of them the difference between the actual amount and what it predicted. And whoops, I need to give myself a little room to work here. This is just a, oh boy. There it goes. I needed to give myself some room here on my plots. But this is something I can do from R. And what this is telling me is that, you know, these are the different data points. I think I had 151 predictions, and this is just telling me how, you know, a value of 0 means that there was a perfect prediction, and anything that was away from 0 was a bad prediction. So you can see, generally speaking, that this model down here, the variance was closer to 0. So I'm going to use my decision tree going forward. So in RStudio, what I've done here is we've just kind of experimented with 2 different regression models. We've figured out which one we like better. At this point, I'm ready to move over to SQL Server. Okay. So I'm going to close that, and that's what I'm going to do. Now, I happen to write these things or put them together in Visual Studio and deploy them in SQL. But this is the stored procedure that I'm going to use to generate a model. And I'm using the same model that we did before, where I'm using this decision tree here. Same code, because this is the model that I know that I want. But what I'm outputting here is my trained model. I'm using this serialize function to take the structure of that model and return this as a binary output. And so I've deployed this stored procedure. And now from SQL Server, let me just take a look at my table here. I'm going to wipe out this table just for the purposes of this demonstration. And what I'm going to do here is I'm going to run this stored procedure to generate my model. And I'm going to, let's just query this real quick. We'll see what this looks like. Inside this stored procedure, I am running sp execute external script, which is calling out to R. So I'm calling a stored procedure that calls a stored procedure that generates R, or that executes R. And the output of this is this binary model. And what I want to do with that is just store that model in my table. And so I just did a simple insert here. I just inserted into this table I've got called rental model, and I've just passed that value in here. And now we should see that I have a model stored. Now I can keep this here. If I want to retrain my model, I can do that over time just by executing this generate rental model. But now that I have this, let's use this in a prediction. This is that third step of my SQL Server workflow, where I've got this stored procedure that I wrote called predict rental count. And again, this is all made available in the demo. But this stored procedure is called predict rental count. And what this is doing here, in a nutshell, is if I can find it, is it's running this prediction again. So we're passing it a model, which is right here. This is that binary output that we're reading from our table. So we generated binary, we're passing it into this prediction, and we're passing it a data set here that we're calling rentals. And the data set is this query here. I've got just two quick examples. This is just a query that's just passing in one row of data. So I'm passing in this model, and inside the stored procedure, sorry, I didn't explain that very well. It's going to be selecting, so in here it's reading that model from this model table. So I'm telling it which model to run. This stored procedure will query it and then pass this down to my external script, which runs the R. And so if I run this, we've now run the prediction. So what I did is I passed a static value here. I said the month was March and the day was the 24th. It's this day of the week. It snowed this day and it was a holiday. And based on this information, it predicts that I'm going to rent 332 sets of skis on that day. Okay. Now I can do kind of a bulk, if you will, where rather than passing in a single record, I'm going to pass in the entire 2015 data set here, and I can run this, and that now returns me 151 predictions. Now the output here is just simply the rental count, so there's no way on this particular output to correlate that to the day that I input, but we can change our output to do that. But in this particular example, it's just returning me that single output. Now the last piece that I want to show you for a demo is using that native SQL predict function. But to do that, we need to kind of regenerate our model in what's called native format. So going back to our SQL Server pattern, I'm kind of starting at the beginning where I want to generate a model. And so to do that, I have another stored procedure that just is called generate dtree. This one here, the generate the native model. And without getting into details, the biggest difference here is on this outputting of our trained model is that I'm still serializing it, but I've got to provide this parameter here of real-time scoring. And so this is just providing the same model, but in a native format that's understandable by SQL. So it's really the same model, just kind of a different format. And this store procedure is very, very similar to the one we ran earlier, where we generated the one that's not native. So if I come back over here to SQL Server, I'm now going to generate my native model. And again, this native model is the one that I want to use with the predict. And I'm going to insert that into my rental model here. So when I run that, I just have a select statement here to show me the model. It's inserted that model into this table. So let's just take a look to make sure that it's in there. And sure enough, so now I've got two different models in this table, one that I've just called dtree native. And you can just see just visually that they're at least different. I mean, we have no idea what these are really doing, but they are indeed different formats. And so using this native model here, I want to use that in the SQL predict function. And I mentioned this earlier, but at this point, what I'm running is not really using R, or the R service. It's using this binary model that was created by R. But at this point here, I'm just running a SQL query. So I've got a couple variable declarations up here. I'm going to select my model, just verifying that that works, and I will pass this as a parameter to the predict query. I also have to provide some data in here. So to do that, I just created a little CTE here that is just my 2015 data. So this is saying, okay, based on the model that was built based on data from earlier in 2015, let's do some predictions of what the ski rentals were for the year 2015. And if I execute this, and here in this case, I've got a nicer data set, but this is just using native SQL functionality to invoke a model that was generated with R. And so now I can see that for this particular day in 2015, that we've predicted that I will rent 40 sets of skis, and so on. So now I can take this data, as output. I can put this into a table, do reporting on it, etc., and help manage my business that way. I went pretty quickly through the demo, but there was a lot of material to cover there. But that was it for the demo. So we've covered a lot of material today. We started with an overview of R and Python and how they can be used for machine learning. We talked a lot about the product called SQL Server Machine Learning Services, how we can develop R and Python to be used from within SQL Server, and then finally how we can execute R or Python and generate predictions from within SQL to use in an application or to help run my business. Liz, that was everything I had today. I just want to thank everybody for their time, and I'm available to take a few questions.
Yeah, sure. We've got several, so we'll try and get through as many as we can. First question is, can you use R in Oracle?
I don't know the answer to that. I will take that as a follow-up. I don't know.
Okay.
I mean, you can, and let me just say something though. You can use R to connect to Oracle. So if your data is in Oracle, you can use R, kind of like I did back here in R Studio. I connected up here to a SQL Server database. You can connect to Oracle, but I don't know whether Oracle has a similar integration with R the way that I demonstrated here with SQL.
Okay. Is there a security consideration risk with enabling external scripts?
Yes. Yeah. So yes, there's a security concern, or not a concern, but depending upon your environment, some places will allow for you to run external scripts and others will not. But you can also control that, as far as who has access to run these stored procedures, et cetera.
Okay. All right, this is a long one.
Okay.
Since R runs outside of SQL Server, is there any performance benefit to running R inside SQL Server, or is it more a convenience benefit of not having to export your data out of SQL Server to a text file for R to use?
Yeah, so let's talk about the last part. Yeah, part of the benefit is that you don't have to do that exporting your data anymore. You can use R to query the data without having to export it to some other format and pass it across the network, et cetera. And I'm sorry, Liz, can you repeat the first part of the question?
Sure. Let me go back to it real quick. Is there any performance benefit to running R inside of SQL Server?
Versus?
I guess, running it in the cloud.
Oh, yeah, I'm sorry. The answer is yes. I mean, so when we install R or Python with machine learning services, yes. If the code is written to take advantage of some of the advanced features that are installed, there's definitely a performance benefit, particularly if you're using larger data sets. But again, just removing that latency and having to shuffle data across the network is a benefit as well.
If my production server is an older version of SQL, can I stand up another server just for R services and use that to pull data from the old server, run the scripts, and then write back to the older server?
I think I followed. I think the answer is yes. I mean, you can stand up a SQL Server instance with R, connect to a older instance and run predictions, and then output that to your old one. I mean, yeah, you if you've got all the connectivity worked out, yes, you could do that.
All right. Someone was asking if you were going to share your code.
I can, yes. I mean, I can package it up. Liz, we can talk afterwards about how it'll go out with the slides. I would also say that this is available on that link I provided. I've made a couple small tweaks just for some personal preference kind of stuff, but yes, we can provide the code that I have here.
Sorry, just running through everything.
Yep.
Why would we prefer one execution path over the other?
I'm not sure I understand that question. So one execution path.
Like at the last little bit of your presentation. So I don't know if that helps.
Okay. So executing in SQL versus executing in R. Yeah, I mean, I think that doing it from SQL would add an extra step. I mean, you have to have that model stored. Whereas I could have consolidated some of my other code to do the generating the model and the execution kind of all at once. So no, I guess it doesn't. I guess personally, it's a little bit simpler to get the output out of the predict function, and it's also you're using SQL Server at that point and not R. So I mean, if you prefer that route, that would be a reason to do that.
Okay. Was all the R code using just base R, or were there specific packages used in building the models?
A little bit of both. So like anything with RX here is part of that Revoscale, which comes with the SQL Server machine learning installation. So this is not part of base R, but it's part of the base of what's included with SQL Server. And other than that was it. I didn't use anything outside of what comes with SQL Server.
Okay. I think we have time for one more question, and then I'll make sure Bob just send you all the ones that we did not get to. Can you use SQL ML to auto-update, retain your model?
Yes. I mean, yes. Yep. So that was kind of the idea here. Now you have a couple different options here. If I go back here, that was kind of the idea with this generating here. I can regenerate this, and the output of this, I can either overwrite an old model or I can add a version of it. That's kind of why I did this table, and this table comes with the demo, by the way. But this is kind of the advantage of storing this, is then I can kind of manage that. So if I want to keep history or overwrite it, I mean, I could have just overwritten it and keep one model. But yes, you can definitely use this to retrain it. So the idea here would be that if my underlying data has changed and I just want to retrain the model, all I have to do is regenerate it, and it'll rerun or rebuild the model based on refreshed data. All I have to do is run that store procedure. So yes, for sure.
Okay. All right, great. So unfortunately, we're out of time. So thank you, everybody, for joining us. As I mentioned, I'll be sure to send Bob all the questions that we didn't get to. I know there were several, and we always do a follow-up blog after each webinar that has the presentation files and questions that we didn't get to. So please go to blog.pragmaticworks.com. You can find them all there. I would recommend signing up for updates so you can kind of see when they come out. As always, the session was recorded, so you will be getting that link tomorrow. If you need anything else before then, Bob put his his email up on the screen there, so you can email him directly, or you can email any of us at Pragmatic Works. We'll be happy to pass along your information. Bob, thank you so much for another great presentation, and we'll see you guys on the next one.
Thanks, everybody.